Welcome back. This is the second stream of the week. We are continuing object-oriented programming. We had a wonderful stream on Monday. I mean, I really pushed myself and like to absorb the knowledge and really. And we had our first end of stream summary, where we basically discussed. We have methods which are with underscore. Beautiful soup is a library which returns object when used, and blah 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 blah. Anyway, the main takeaway from the last stream is that we're not gonna announce an end goal. We are continuing and really critically read everything, and trying to approach it with an open mind as usual. And let's get right into it. Where are we? Yes, so this is the cookie cutter part. I remember, yes. This is very heavy. So I just gonna read it again, and we will see. At a basic level, an object is simply some code plus data structures that are smaller than a whole program. Defining a function allows us to store a bit of code and give it a name, and then later invoke that code using the same function, using the name of the function. An object can contain a number of functions, which we call methods, as well as data that is used by those functions. We call data items that are part of the object attributes. We use the class keyword to define the data and code that will make up each of those objects. So see, this is very important because we use the class keyword to define the data and code that will make up each of the objects. The class keyword includes the name of the class and begins an indented block of code where we include the attributes, data, and methods code. Each method looks like a function, starting with the def keyword and consisting of indented block of code. So this is something also from last session we know that when you call a function, there are brackets, and we basically have the function before on the left side. And when you call a method, you have dot notation, and you have the affected variable dot. No, I think so. I wrote it down here. You guys don't see it. I'm gonna show you. So here I made some other notes, right? So function, whatever, the item dot method. So dot notation, yes. So clear. Okay. Moving on. The first method is a specially named method called underscore init. This method is called to do an initial setup of the data we want to store in the object. In this class, we allocate the x attribute using dot notation and initialize it to 0. Self.x equals 0. The other method named party. The methods all have a special first parameter that we name by convention self. The first parameter gives us access to the object instance so we can set attributes and call methods using dot notation. Just as the def keyword does not cause function code to be executed, the class keyword does not create an object. Instead, the class keyword defines a template indicating what data and code will be contained in each object of type party animal. The class is like a cookie cutter, and the objects created using the class are the cookies. You don't put frosting. Why? What is this 2 here? Alright, whatever. Moving. Here. We have a copyright. You don't put frosting on the cookie cutter. You put frosting on the cookies. And you can't put different frosting on each cookie. If we continue through this sample program, we see the first executable line of code, n equals party animal. This is where we instruct Python to create an object or instance of the class party animal. It looks like a function called to the class itself. Phew, this is so not fun, guys. Like, this part is just like, okay, thanks. Ja Istenem, ja Istenként. Oh. We went through this, right? We went through this. I think we did. Did we or not? Yeah, so I broke down this code down. Absolutely, I did. Okay, so let's approach it from this angle. So the init is a built-in, automatically called when a new instance of class is called. It's a built-in special method which is called when a new instance of a class is created. The other method is named party. The first parameter gives us access to the object instance. I'm just gonna remove the sunlight. The first in this class, the first parameter gives us access to the object instance, so we can set attributes and call methods using the dot notation. The first parameter, so okay, I did write this down word for word, but we're gonna rewrite it in my own words. So the first parameter gives us access to the object instance, so we can set attributes and call methods using the dot notation. The first parameter gives us access to the object instance. The first parameter. So the parameter is the self. I cannot write this any better. Adding the self as a parameter, as the first parameter to underscore init to the init method Adding the self as the first parameter to the init method gives us access to the object instance, so we can set attributes and call methods using dot notation. Gives us access to the object instance, so we can set attributes and call methods using dot notation. So this guy here enables this. It makes it possible. Just as the def keyword does not cause function code to be executed, the class keyword does not create an object. Similarly, as the def keyword does not cause function, I cannot write it down word for word. You remember, Kerge, we cannot do that shit. So let's just make it nicer now. Today, when I finished, I was so like, I took down the cat for a walk, as well as I did on Monday. I think it's a nice way to go down into the, you know, get some fresh air. I was even standing in the sun and without a cell phone, right? Without anything really, but I felt so incredibly tired. Like, it's so demotivating to feel this way, to be honest. It's just really like the complete. Anyway, so the init method is built-in special method, which is automatically called when a new instance of class is created. The other method name, should we tag this? Yeah, of course. Yeah, oh, cool. Similarly, as the def keyword does not cause function. Similarly, as the def it's a template, defines a template indicating what data and code will be contained in each object of type party animal. Indicating what code and data will be in each object type called party animal. The class is a cookie cutter. This is where we instruct Python to construct, create an object or instance of the class party animal. It looks like a function call to the class itself. Yeah, it looks like a function call because here's the name and it's an empty bracket. I guess that's what you mean. Function call to the class itself. Python constructs the object with the right data and methods and returns the object, which is then assigned to the variable n. In a way, this is quite similar to the following line, which we have been using all along, which is counts equals dict. Here we instruct Python to construct an object using the dict template already present in Python, return the instance of dictionary, and assign it to the variable counts. When the party animal blah 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 blah. When the party animal class is used to construct an object, the variable n is used to point to that object. We use n to access the code and data for that particular instance of the party animal class. Each party animal object instance contains within it a variable x and method / function named party. We call the party method in this line and that party. When the party method is called, the first parameter points to the particular instance of the party animal object that is a party and is called from. Within the party method, we see the line. This syntax using the dot operator is saying the x within self. Each time party is called, the internal x value is incremented by 1 and the value is printed out. The following line is another way to call the party method within an object. In this variation, we access the code from within the class and explicitly pass the object pointer n as the first parameter. You can think of n.party as a shorthand for the above line. When the program executes, it produces the following output. The object is constructed and the party method is called 4 times, both incrementing and printing value of x within an object. Okay. So this is it. This is the line. Everything we have here, now it becomes. So let's do a sample code. Okay, let's do a very nice sample code now. That's something which we should, because again, I didn't check if it works. So if I change to Python now, cool. No, it's not working. Wait. Boom. Perfect. So I'm gonna have it here. So I'm just gonna rewrite the code, obviously. So what should we want? So let's think about something, you know, not negative, but also like melancholic shit. Party mix. So class, I create the class, then I initiate it. Self is a party, and self dot x is gonna be equals to 0. Jesus, I have absolutely no idea what's going on. So let's write equals Oliver. Which is the name of my cat. And then we're gonna say self.x equals self.x. So it means it's gonna be equaling Oliver plus likes. Yeah, but plus likes. So every time we call, what's the point of this? So def party self. Jesus Christ. No, thank you. I don't want to update iTunes. Okay, it's working at least. Ooh, it smells like food very strongly. Somebody's cooking up something good. Olivia likes, Olivia likes, Olivia likes. So Control F, Control F5 doesn't work for some reason. Do I have something on or what's going on? Fn plus F. I don't even have function key. Whatever. So can we add more stuff to it? But then it's immediately gonna be this one, right? Because how many times? Yeah, it's gonna add everything. Or yeah, wait. Yeah, again, you're making a little test for yourself, but you don't even know what you actually want. Like, you're not thinking it through. Like, we just want to like mess around. Okay, so instead of numbers, we're gonna use an object to say Olivier likes party mix. Olivier likes party mix. But this is working because it's creating like a you can, every time you call, it increments it, or like add another number. But like I don't know how you're gonna add this. Can I add multiple of these stuff? Okay, so it cannot be indented. But it's interesting because, like, why not? I have no idea what's going on. Why can I put it there? See? These guys are like super tight. And it immediately goes back. That's super weird. Okay, so yeah, you're trying to do something which is like, no, absolutely not. You cannot add another one. Calm down. Can I add multiple def into one class? Yes, you should be able to do that. Here you go. Everything. Yes, something is up with the keyboard, definitely. Yeah, I think I have F lock. F lock is enabled. I had this issue before. I remember that was some silly setup. Ah, okay, I'm so silly. Okay, I knew there was something. Okay, wow, okay. Okay, I'm gonna close the door. Are you gonna come inside? Come inside, boy. Come. You're so beautiful. Come over here. Say hello to the non-existent viewers. Come, baby boy. I'm gonna order food for you, okay? You're gonna have some nice dinner. Come, let's go. Let's go. Say hi. Take over the stream. Please do some Python. Ah, shit, okay, no. Okay, little toilet break. Because why not, right? Toilet break is legit. We've been doing this for 30 minutes. I can't believe I just got panicked for a F-lock, which is just right here. It's insane. But yeah, what did we get from here? Yes, we can create multiple. Yes, we can create multiple definitions. Like what are these? We just wrote it down, right? Yeah, I'm not even gonna go for break. I'm just gonna use the toilet very quickly. Hi. So the object is well, no. Well, the object is made of with the data and methods declared in the class. So now we can, for example, bazd meg. No panic. Oh, okay. So the dict template using the cookie cutter class here. So we're gonna ask our buddy ChatGPT what is inside. Or actually, what was the option? I think dear. But dear meant what kind of an option, what kind of a methods are inside, right? Stuff equals list. Dear stuff. The capability is of an object, right? So the object is already something which is constructed. But what are the capabilities, or how does the built-in class look like? How does it made of? So this is actually a wonderful thing to check. So let's see. Can you see the ChatGPT? Right. I think no, I'm gonna do it other way. I'm gonna duplicate this tab. I'm gonna put it right here. And anytime we're gonna use the codes, perfect. Yeah, that's it. Zoop, zoop. Oh my God, what the fuck am I doing? So what is inside? But dict is not a template, is not the class. Is not the class, it's the template. Wait. Class, yeah, it's the class. What is inside of the dict class? Jézusom. Cool. Do, 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 do. Whatever. Okay. Cool. Moving on, moving on. When the party animal class is used to construct an object, the variable n is used to point to that object. We use n to access the code and data for the particular instance of the party animal class. Each party animal object instance contains within it a variable x and the method function named party. We call the party method in this line. When the party, the first parameter reaches blah blah blah. Okay. Optimization. I cannot write. But it should give you an idea. So basically, the object is assigned, as I wrote above, the object is assigned to the variable, but actually so it's immutable. But it's actually, it's only pointing to the object. Of the party animal. The cat is sleeping. The cat is happy now. Variable, we use n to access the code and data for that particular. Each party animal object instance contains within it a variable x and a method. We call the party method in this line. But we can test this if it's immutable or not immutable. N equals party animal. N dot, oh, Isten, this is very crazy. So print N. Yeah, because you're not changing the, yes, exactly. You're not changing the variable itself. Yeah, exactly. Perfect. But it's actually only pointing. We use the variable n to access the code. The variable itself will only have this. Boom. So it only gives us the option to access As I wrote above, the object is assigned to the variable n, but actually it's only pointing to the object. We use the variable n to access the code for that particular instance, and itself will only have this, so it only gives us the option to access. I mean, I don't know if it's reasonable to write it like this, but you get the idea. It's not gonna become the class itself. It's a pointer. It's okay, like this is the big brain part, and it's gonna be so far, so far when it's gonna be, but it's, I still think, it can make sense eventually. Each party contains within it, each instance contains a variable. Each instance of party animal contains a variable x and, oh shit, sorry. Yeah, we should really like clear up, because why would you want to use two different ways? When the party method is called, yeah, okay, so let me brain fart a little bit. So I still believe that, this is whatever am I doing right now, and since January and everything, like, these are like we are in a little boat, and the whole like sea is Python, or the journey is to learn Python, let's say, to become programmers. But we are like, but the amount we are doing right now, and the approach is like really like little boat, and getting to the other side or something, that will be like, and so we are moving slowly, but ideally, if we can't, we're still doing this, like, so we are moving very slowly, and sometimes we are getting to a wave, right? Like there's thunderstorm, and there is like we basically crash, and then we don't even dealing with Python, but then we assemble it again, and we are trying to do it again. And so eventually, like, you get the knowledge. But yeah, I still think that the only way to do this is that when there will be a point where you can you create your own stuff. Like, you want to create, like, I want to do this, and I feel ready, or I have enough information. And then if that moment will it will be like rocket fire, that now you're obsessed, and then you are basically, the only way to do this is really like you are obsessed, and this is your primary thing. And because that will drive you from the inside to be better and to learn more and become, you cannot half-ass this. There's no possibly you can half-ass this. Yeah, thank you for coming from something stinked my ear. This is when I went away before. But I guess it's just my fucking paranoia. When the party method is called, the first parameter, which we call, points to the particle instance of the particle object that party is called from. So when the party method is called, so we are calling it right now, right? Boom, here. And it means this is the first one, right? And that will include oh my god, how to rewrite this? The first method is called, the first parameter points to the particle instance of the party animal object that part is called from. The first parameter, which is the self, so we are calling, points to the particular instance of the party animal object that party is called from. Within the party method, we see this line, self.x equals. The syntax using the dot operator is saying the x within self. Each time party is called, the internal x value is incremented by 1 and the value is printed out. The following line is another way to call the party method within an object. PartyAnimal.party. In this variation, we access the code from within the class and explicitly pass the object pointer as the first. You can think of n.party as shorthand for the above line. Ah, goddamn. Tu 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 tu. This syntax using the dot operator is saying the dot operator is saying here Man, I have so many problems. I'm pretty sure. Whew, I'm gonna get some water. Okay. There is another way to call the party method. But see, you are not making this easier for me, because now, so for now, before we just established that, hey, the n is actually just like a pointing, is pointing to an object, but not actually is the object. But now we are saying it's actually an object. So what is it then? What is it? We can actually check here. So, okay, I'm stupid. Yeah, it says, okay. In this variation, we access the code from within the class and explicitly pass the object pointer n as the first parameter. In this variation, we access the code from within the class and explicitly pass the object pointer n as because it's an object pointer. See the pointers within the an object. So party animal is the class. We use the dot notation to use the method on it, and then we use n. In this, we access the code from within the class and explicitly pass the object pointer n as the first parameter. In this way, Why 4 times? Why 4 times? It's not even 4 times. Because we're gonna add this one as well. Okay. Oh, we are done with this page. As we have seen in Python, all variables have a type. We can use the built-in dir function to examine the capabilities of a variable. We can also use type and dir within the classes that we create. So again, initializing the self, and it's gonna be 0. Def party self, blah blah blah. Okay, that's very nice. I'm curious. You can see that using the class keyword, we have created a new type. From the dir output, you can see both x integer attribute and party method are available in the object. Can you imagine that people spending time on Destiny or any live service, like literally, and like that amount of time you can do this? Or yeah. X, exactly. So the dir is gonna be, okay, so Object lifecycle. In the previous examples, we define a class, a template, use that class to create an instance of that class, object, and then use the instance. When the program finishes, all of the variables are discarded. Usually, we don't think much about the creation and destruction of variables, but often as our objects become more complex, we need to take some action within the object to set things up as the object is constructed and possibly clean things up as the object is discarded. If we want our object to be aware of these moments of the construction and deconstruction, we add specifically specially named methods to our object. Do, 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 do. Oof. What happened here? Oh my god, I broke it. I broke it, guys. God damn it. Why does it look like this? It was supposed to give me like, you know, nice colored way of doing this. I don't understand. That's so weird. Ah, because it's not selected from here. So, we know what it means to define a class, and we know that it's used to create I am constructed. As Python constructs our object, it calls our init method to give us a chance to set up some default or initial values for the object. When Python encounters the line n equals 42, it actually throws our object away so it can reuse the n variable to store the value 42. Just at that moment, when our n object is being destroyed, our destructor code del is called. We cannot stop our variable from being destroyed, but we can do any necessary cleanup right before our object no longer exists. When developing object, it is quite common to add a constructor to an object to set up initial values for the object. It is relatively rare to need a destructor for an object. Yeah, makes sense. This line overrides the previous object. Makes sense. I think this is fair enough. Okay. God damn it. Oh, I should be here. This should be little tuples. So far, we have defined a class, constructed a single object, used that object, and then thrown the object away. However, the real power in object-oriented programming happens when we construct multiple instances of our class. When we construct multiple objects from our class, we might want to set up different initial values for each of the objects. We can pass data to the constructors to give each object a different value. What does that even mean? cookie cutter class, little cookie cutters. So far, we have defined a class, constructed a single object, used that object, and then thrown the object away. However, the real is when we construct multiple instances. The real power of object-oriented So we are initializing self num. Self.name equals num constructed. The constructor has both a self parameter that points to the object instance and additional parameters that are passed into the constructor as the object is constructed. Within the constructor, the second line copies the parameter that is passed into the name attribute within the object instance. We need to write it with our own words. We need to write it with our own. So this is the constructor. Additional parameters. But there's only one additional parameter. Within the constructor, the second line copies the parameter that is passed into the name attribute within the object instance. Within the constructor, the second line copies the parameter that is passed into the name attribute within the object instance. The output of the program shows that each of the object S and J contain their own independent copies of X and num. We are at inheritance. This is absolutely crazy. Ki ez az állat? Ki ez az állatka? Let's try this. Maybe it will make more sense. So, God damn it. Yeah, but it doesn't make sense. Yeah, the problem is within the class, we cannot do this. We cannot really do the debug shit. Right, that's the problem. Yeah, because we would have to like sell this constructed. Yeah. Ja, Istenkém. We have the self, right? And the self.x is gonna be 0. Then we have the self.name. So this is all happening inside the constructor. So here, a lot of things are already happening in the constructor. Constructor. Son of a bitch. Self parameter points to the object instance. Self parameter points to the object instance. And additional parameters. So S equals Sally. I'm really trying, guys. Like, I'm really trying. Like, I don't want to chicken out, you know. I don't want to, like, doing both. But I'm really trying to piece it together. And it's just, like, it's just such a deep-minded state to understand. Like, to actually, like, really say, like, okay, I understand. This is just way... This is the point where it's like, what the fuck? Yeah. Bro. Helldivers 2 community manager has been fired after encouraging players to review bomb games. Community manager. But they actually, like, there is a girl from the Destiny 2 community manager. She's looking for a job, so maybe she can go there. We need to understand it. And we have the power. The reason why this is confusing still, because we don't actually, like, we just passed this, right? Well, what is the .x? Right? This is like very, very heavy topic. Extremely heavy topic. Let's see the whole thing. See? Like, this is such a big topic. Like, this is something you can, like, okay, let's review again. Here is the cookie cutter. I'm gonna declare a class, and everything which is inside here is the shape, the template, which is gonna be filled with code and goodies. We're gonna fill it with goodies, right? I'm gonna define the initialize. This is the constructor, and this is must. Every time you create a new class, it's gonna construct the object, and the self is gonna be the method. Okay, so right, I'm constructing the object, and I'm using the method. I'm also creating, like, the method. For some reason. But yeah, this is like, we create we initialize. This is the constructor, and the self. Okay, so the self itself. Yeah, basically we're creating the method here. Then adding the self as the first parameter to initiate gives us access to the object instance, so that we can set attributes and call methods using the dot notion. So if we add the self, gives us access to the object instance, which means that from that point we can use self to do shit. The self is gonna be our main tool to do stuff in the objects. And then we can, which gives us, and the way we're gonna use it is with the dot notation. So the dot x. So we allocate the x attribute using dot notation, initialize it. So anytime we're gonna use our method inside the object and use dot, anything we add next to it is an attribute. The x is an attribute. The dot operator is saying the x within self. X within self. Highlight that shit. Each time part is called, the internal value of x is raised. So which means, so the dot x is an attribute, which means here again, dot the x within self is a 0, the attribute. Now we're adding a second attribute. We add a second attribute, and the value is the num, the second parameter. The second line copies the parameter that is passed into the name attribute. Within the second line copies the parameter num that is passed into the name attribute within the object instance. I need another T. I'm gonna have another T. But this is good. I think we are starting to grasp. We starting to grasp it. I think so. Okay. Okay, 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 okay. Self.name equals num. Self.name constructed, or num. Within the constructor, the second line copies the parameter num that is passed into the name attribute within the object instance. The output of the program shows that each of the objects S and J contain their own independent copies of X and num. So we have self.x, which is a 0, and then we have the name. And then we're gonna do another one, which is gonna +1. We're gonna just add 1, party count, are there hotkeys here? I'd like to just switch to the code anyway. No, this is a good stream. So this is I'm very satisfied with this, because like I give it time. I don't feel like I'm triggered, and I do, I feel very small and tiny, but I do ask, like I do actually like, okay, what is really happening here? And yeah, I still don't think I actually know, but I ask. This is exactly what I would like from a stream, from these moments. Anyway, so this is gonna be a testing too, because now what did I wanted to do at the beginning of the stream? I wanted to add a name, right? So in here, when we construct the objects, well, okay, let's not call it that. It's just the constructor. I'm gonna look at myself. So here's the constructor, and it's gonna be the name. What do you wanna do? So let's put Olivier and Olivier. So which means there can be two separate instances. Olivier constructed. Olivier party count 1. But can I only have 2, or I can have multiple ones, like epsilon? So cool. So just because we have one additional parameter, it means we can have multiple of the same. Let's do it one more time. Yeah, the Machkov in the, ooh, this is absolutely crazy. So the same class is used and as a number. So the second attribute and the value is how you summarize this. Keeping track of their x. Another powerful feature of object-oriented programming is the ability to create a new class by extending an existing class. When extending a class, we call the original class the parent class and the new class the child class. For this example, we move our party animal class into its own file. Then we import the party animal class in a new file and extend it as follows. This is a topic we actually discussed in the pub recently. We talked about it. Oops, sorry. Okay. When we define the cricket fan class, we indicate that we are extending the party animal class. This means that all of the variables x and methods from the party animal class are inherited by the cricket fan class. For example, when within the 6 method in the cricket fan class, we call the party method from the party animal class. We use a special syntax in the init method in the cricket fan class to ensure that we call the init method in the party animal class, but so that whatever setup that party animal needs is done in addition to the setup needed for the cricket Clio cat. Okay, see? Hey, Mr. Chuck. The super syntax is telling Python to call the init method in the class that we are extending. Party animal is the super or parent class, and the cricket fan is the sub or child class. As the program executes, we create S and J as the independent instances of party animal and cricket fan. The J object has additional capabilities beyond the S object. In the dir output for the J object, we see that it has the attributes and methods of the parent class, as well as the attributes and methods that were added when the class was extended to create Okay, so the only way this can work, I don't think this is gonna work without. Yeah, we need to create our party animal. From party, no module named party. I'm confused again. But it's there, literally it's there. So I don't understand. We move our party animal class into its own file. Then we can import class in a new file and extend it. Ah, okay. Yeah. That's it, yeah. Party. We're gonna name it party, and now it's working. Yeah, okay. And I think it should be the last one. Should be the last one, not the yeah, the first one. This is already our class, the main class. So yeah, let's try that. Or we can just say from party 5. Yeah. For this example, we move our party mode. Yeah, okay, that's done. Fucking bullshit. This means that all of the variables, x and methods, so we should already pull up and put here next to it the what was in party 5. I'm sorry. Boom. This means that all of the variables x and methods from the party animal class are inherited. But so is it attribute or variable? We should fucking decide what are we calling what, because like this is making me crazy. Let's decide on what are we calling them, no? We use a special syntax in the init in the constructor to ensure that we call init in the so that whenever setup the super syntax is telling Python to call the initiate method in the class that we are extending. Party animal is the super or parent class and is the subclass. Okay. La 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 da 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 pa da 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 pa 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 wow wow. As the program executes, we create S and J as independent instances of Party Animal and Cricket Fan. The J object has additional capabilities beyond the S object. So this is very interesting, and this is good because in real life scenarios, like many times when I look at code, you have, import pandas or from blah, 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 import. So it means, you kind of get the idea that it's like how this should work under the hood. I don't know, I just feel like really we are so getting the knowledge to actually use in IT is gonna be so unbelievably different to this. I mean, yeah, okay. Obviously it will be, but we are taking step by step. You're doing great, Kerke. You're doing great. Yeah, we understand. I guess we don't need to add anything here. We understand inheritance. It's basically what means is that you're gonna import. You have a file which has a class already established, and we importing, but we adding the file name, right? That's it. And then we can use whatever we import. And if we create, yeah, in there, like now if we use the class, yeah, we basically, yeah, it makes sense. Why would you do this? What would be the use case? No idea. That's too much for my brain right now. But we understand that this exists and it's useful. Summary, let's leave. This is a very quick introduction to object-oriented programming that focuses mainly on terminology and the syntax of defining and using objects. Let's quickly review the code that we looked at the beginning of the chapter. At this point, you should fully understand what is going on. Yes, we understand what's going on. We are basically saying that stuff is going to use the list cookie cutter. And in the list cookie cutter, we have the append method. And we're gonna add our own little variables to it. And we're gonna use another method to sort them. I guess so. The first line constructs a list object. When Python creates the list object, it calls the constructor method to set up the internal data attributes that will be used to store the list data. We have not passed any parameters to the constructor. When the constructor returns, we use the variable stuff to point to the return instance of the list class. The second and third lines call the append method with one parameter to add a new item at the end of the list by updating the attributes within stuff. Then in the fourth line, we call the sort method with no parameters to sort the data within the stuff object. We then print out the first item in the list using the square brackets, which are a shortcut to calling the getItem method within the stuff. This is equivalent to calling the getItem method in the list class and passing the stuff object as the first parameter and the position we are looking for as the second parameter. At the end of the program, the stuffed object is discarded, but not before calling the destructor named del, so that the object can clean up any loose ends as necessary. Those are the basics of object-oriented programming. There are many additional details as to how to best use object-oriented approaches when developing large applications and libraries that are beyond the scope of this chapter. let's wrap it up. Yeah, let's wrap it up. I'm gonna wrap it up now. And Saturday we gonna do mega stream. We're gonna do a mega stream on Saturday. And tomorrow I will try to just, go through this summary again. Yeah, and mega stream on Saturday, and we're gonna go to SQL and everything. So be on the lookout for that. Okay, Naskladano.